Hello everyone, my name is Riya and today in this video I'll be explaining how to write the code for displaying the Floyd's triangle. So first of all we need to understand how does this Floyd's triangle look. So this is a Floyd's triangle, and Floyd's triangle is basically a right angle triangle consisting of array of natural numbers, and it is defined by filling the rows of the triangle with consecutive natural numbers. So let's see how to write the program for this, for displaying this pattern. And here first of all I've declared two variables k and I. I've also initialized k as 1, and I'm using two for loops over here. The first for loop decides the total number of rows in the pattern, and the second for loop will decide how many elements are supposed to be there in each row. So since we have initialized k equal to 1, we will be displaying the value of k instead of displaying the value of I and j. So let us see how does it work. Like first of all, when I is equal to 1, we know that 1 is less than equal to 4, so it comes inside of this for loop, and we find there's another for loop, that is for int j equal to I, that is I is 1 is greater than equal to 1. Since this condition is true, the value of k is printed along with the space. So initially the value of k was 1, so 1 is printed, and then the value of k is incremented by 1, that is 1 becomes 2. Now j becomes 0. The value of j was 1, so it becomes 0. Since this condition now becomes false, that is 0 greater than equal to 1, since this condition is false, it comes out of this loop and we move on to the outermost loop, and the value of I is incremented by 1, which was 1 previously. So now it became 2. So 2 is less than equal to 4. This condition is also true. Now we come inside of this for loop, and we see that we have another for loop, that is j equal to I. Now the value of j is 2. Now 2 is greater than equal to 1. Since this condition is true, the value of k is printed. Now the value of k is 2. So in the next line 2 will be printed, and the value of k will be incremented by 1. K becomes 3. And j will be decremented, that is 2 becomes 1, and since 1 is greater than equal to 1, so again the value of k will be printed, that is 3 will be printed. So as of now, the first row consists of 1, the second row consists of 2 and 3, and similarly for the third and the fourth row, and similarly for the third and the fourth row the elements will be displayed. Now let us see how this program runs. Yeah, so we're getting the required output, that is the Floyd's triangle is displayed. Thank you. Hello everyone, my name is Riya, and today in this video I'll be explaining a program which will convert a binary number into a decimal number. Now for that, let us first understand how a binary number is converted into a decimal number. So let us consider this example. So starting from the rightmost digit, each digit is taken and it is multiplied with the powers of 2. So initially it is multiplied with 2 power 0, then the next digit is multiplied with 2 power 1, then the third last digit is multiplied with 2 power 2. Similarly, the power of 2 increases until we reach the leftmost element. Now the product that we have obtained over here, all these numbers are added, and finally we obtain a number which is the decimal equivalent of this binary number. Now let us see how this program runs, and for that the user has to enter a binary number, and for that I'm using scanner class over here, which is available in the utility package, and I'm storing this binary number in b variable, which acts as a temporary variable over here. Now I've done this so that the original value does not get disturbed, and I've also declared a temporary variable over here which will be used in the later section of this program, and I'm using a while loop here which will be running until the binary number which was entered by the user becomes 0. Now for performing this operation, for performing the conversion operation, we have to fetch each and every digit of the binary number. For that we have to divide, we have to perform modulus operation over here, that is b mod 10. Now when we perform this operation, each and every digit of the binary number gets separated and it is multiplied with the powers of 2. Now this loop will run until the binary number becomes 0, and moreover the original value of the binary number is also preserved. So it comes out of the loop once b becomes 0, and finally we obtain the sum, that is the decimal equivalent of the binary number. Now let us see how this program runs. So I'll be entering a binary number, for example 1010. We know that the decimal equivalent of the binary number 1010 is 10. Now let us see some other example. Suppose if I am entering 1 8 times, so it will display 255. Yes. So this is how my program runs. Thank you.